In this problem, we're going to look at discontinuities of a rational function. We'd like to determine where the rational function r of x is undefined and determine whether an asymptote or a hole appears at such numbers. We'll begin by factoring the numerator and denominator for our rational function. We'll have r of x is equal to, and in the numerator we're going to use factoring by grouping. We'll group the first two terms together and the last two terms together. The first two terms we can pull out an x squared, so we'll have x squared times x plus 6. In the last two terms we can pull out a negative 4, so we'll get minus 4 times, and x plus 6 is left. In the denominator we can factor that as x plus 7 times x minus 2. In our numerator we can pull out the common factor x plus 6, so we'll have x plus 6 times what's left, which is x squared minus 4. And we rewrite our denominator, x plus 7 times x minus 2. Now here x squared minus 4 is the difference of two squares. We can go ahead and factor that a little further. So we have x plus 6 times x minus 2 times x plus 2. And all over x plus 7 times x minus 2. Now our first step is we're trying to find all the values where the rational function is undefined. When we do that, we do not cancel any common factors that might exist. We notice that there is a factor of x minus 2 in the numerator and the denominator, but we don't cancel those until we've listed all our values where the function is undefined. To determine the values that make the function undefined, we look at our denominator. We find all values that will make the denominator of our function equal to 0. If we set each of these linear factors equal to 0 and solve, we'll see that our restricted values, that is the values that make the function undefined, are x equal to negative 7 and x equal to 2. Oops, negative 7 and x equal to 2. Because those two values, if we put them in the denominator, will make our denominator 0. Now that we know what our restricted values are, we want to determine whether we have an asymptote or a hole at each of those values. Before we do that, we want to simplify our rational function. At this point we can cancel the common factor. We'd factored the numerator as x plus 6 times x plus 2 times x minus 2. And the denominator is x plus 7 times x minus 2. We had the common factor of x minus 2 that we can cancel. So our rational function simplifies to x plus 6 times x plus 2 divided by x plus 7. And we still keep our restriction that x cannot equal 2, since that was a restricted value. Now that we've simplified our rational function, we again go back to our two values, 2 and negative 7, and we look at our simplified form of our rational function. Any value that was a restricted value that still makes the denominator equal to 0 will yield an asymptote. Any value that was restricted but no longer is restricted will yield a hole in the graph. Since x equal to 2 no longer makes our denominator equal to 0, we'll have a hole in the graph at x equal to 2. The value x equal to negative 7, if we put in our denominator, will still make the denominator equal to 0. Therefore, we still have a vertical asymptote at x equal to negative 7. So our two restricted values for our function were 2 and negative 7. There will be a hole in the graph at 2 and a vertical asymptote at negative 7.